We are now going to study the sides of the different types of quadrilaterals. So we need to know the properties of these various different quadrilaterals also in terms of their side lengths, not only in terms of angle sizes. So first of all, we are going to observe the parallelogram. So a parallelogram have two pairs of sides that are parallel. So we can see this blue arrow, and this blue arrow means that these two lines are parallel. Similarly, the double yellow arrows indicate that these two lines are parallel to each other. Also, these blue lines indicate that these two lines are exactly the same size, let's say 3 centimeters each. The two lines here indicate that this side and this side have the same length, let's say 9 centimeters each. So now let's focus on the properties of a rhombus in terms of the sides. The rhombus is similar to the parallelogram in that both pairs of lines are parallel to each other, but it differs from the parallelogram in that we can see for these yellow lines there are 4 of them, so it means 4 of the sides have the same length, whereas for a parallelogram it's not necessarily the case. So that's the distinguishing property between a parallelogram and a rhombus. So all 4 sides should be the same, let's say 4 centimeters each. Now we study the rectangle. Again, the rectangle is similar to the parallelogram and the rhombus in that 2 pairs of the sides run parallel to each other. Furthermore, it is in fact exactly the same as the parallelogram in the respect that 2 of the sides also have the same length. So we can see these red lines indicate that this side and this side has the same length, let's say 11 centimeters each, and the white lines indicate that these 2 sides, let's say, are 2 centimeters each and of same length. So rectangle and parallelogram are exactly the same in terms of the side properties. So what distinguishes a rectangle and a parallelogram from each other would in fact be the properties in terms of the angles. Now next we study the square. The square, once again, similar to both the parallelogram, the rhombus and the rectangle in the respect that 2 pairs of sides run parallel to each other. The square is exactly the same as the rhombus in terms of the length of the sides properties, because all 4 sides are the same as indicated by the purple lines. So what distinguishes a square in the rhombus is their angle size properties. Next we observe the kite. So the kite is now different from all for the previous ones, the parallelogram, the rhombus, the rectangle, and the square, in the sense that we don't have parallel lines. What we do have is the lines that come together to form the angle. Those lines have the same length. So the two red lines show that this side and this side have the same length, let's say 3 centimeters each. The two green lines show that this line here and this line here that form this angle again have the same length, let's say 7 centimeters each. Lastly, we observe the trapezium. The trapezium in terms of sides have only one property, namely that one pair of sides, as indicated by the greenish blue arrows, run parallel to each other. For exercise 11.4 on page 120, we are going to do number 5. We are given a quadrilateral STUV with one pair of sides, the blue sides, being parallel to each other as indicated by the green arrows, and being of the same length as indicated by the yellow lines. So now if we think of our 6 types of quadrilaterals that we studied, there are 4 of them that have the property that at least one pair of sides are parallel and of equal length. We have the square, we also have the rectangle, then we have the rhombus, and then we have the parallelogram. Okay, but now if we study these 4 candidates a bit closer, we know it cannot be the square, because we are not given information that these are 90-degree angles. The same thing applied to the rectangle, because the rectangle all the angles are 90 degrees, but here no information is given on the angle sizes. The rhombus, we know all of the sides have the same length, and here there is also no indication that in fact all of the sides have the same length. We are only given 2 sides that have the same length. So the only one that remains is the parallelogram, and parallelogram could have angles other sizes than 90 degrees, and the sides could be also of various lengths. So therefore our answer would be that STUV is a parallelogram. Our reason would be that both the or rather this side, SV equals TU as well as SV is parallel to